Okay, so welcome to DIY number 1 for compound events. This is your notes DIY, so make sure you have a clean left and right page in your notebook. We're going to write this on the right side. Remember, at any time you can always pause or rewind if you need to slow us down or see what I said again. This is actually just going to be a small set of notes. As you work through the DIYs, you're going to learn a little bit more about it. So the title is Compound Events. Now first you need to know, well, what is a compound event? An event made up of 2 or more simple events. Now a simple event is like I rolled a dice, I spun a spinner, but I did them separately. A compound event is when I do them together. So when we did sample space, we were doing compound events. We found the simple event of spinning a spinner, and then the simple event of rolling a dice or flipping a coin, and then we said, okay, what if we did all 3 of those? So what we're doing now with the compound events is we're no longer using the sample space to figure out the probabilities. We're actually going to mathematically figure out the probabilities. So there are 2 kinds of compound events. There's independent events and dependent events. And when we set up our notes, we're kind of making it like independent versus dependent. They're both found very similarly, but there is something that is very different between the 2. So an independent event is an event where the results / outcome of one event does not affect the other event. So when I flip a coin and I get heads, that does not affect if I'll get heads on the second coin, or if I spin a red on a spinner, or if I roll a 5 on the dice. They have nothing to do with each other. If I have a box, or in my drawer I have a bunch of socks, and if I pick out a sock and I say, oh, I don't like this, and I put it back, when I pick my second sock, it has nothing to do with it. So things that when I do the first event, it does not affect the second event. Now dependent events, on the other hand, events where the result or outcome of one event does affect the other event. So if you have a set of cards and you pick one card out of the deck and you do not replace it, it affects how many cards there are. If there were 52 cards total, you picked the first one, you did not replace it, now you only have 51 cards left. So it's saying that whatever I did the first time will change what could happen the second time. The big word for that is without replacement, and you'll see that as we move on. So what I want you to do is I want you to go ahead and draw this little box with some gumballs or whatever we want to call these, circles. Now you probably won't have the colors, so maybe inside your circles put an R for red and a B for blue and a G for green and a Y for yellow. So in here there are 10 total. There's 4 red, 3 blue, 2 yellow, and 1 green. Remember, you can pause at any time. So we're going to find the probability of 2 different events. Now, even though there will be stuff on the left and the right, let's start with the left side and we'll come back to the right side, because remember, we're comparing independent versus dependent. So over here on the left, the question says the probability, all right, so sorry about that interruption. So we want to know the probability of picking a red, replacing it, and then getting a blue. So it's like we're going to take this red, take it out, then we're going to put it back, and then we're going to get a blue and put it back. Okay, so the first thing is, well, we need to know, this is the standard notation. You did this with your other DIYs, the probability of red and blue. This keyword and, unlike the word or, the word and means to multiply. So I want to know red and blue. So I'm going to say the probability of red times the probability of blue. So how many reds are there? Well, there's 4 reds out of 10 total. So when I write that, I'll put probability of red is 4 out of 10. Now the probability of blue is 3 out of 10. Now these don't really look like fractions because of the way they're written for the computer, but you can always write them more fraction-like. So multiplying fractions, that's no problem. Top times top and bottom times bottom. 4 times 3, 12. 10 times 10, 100. So 12 out of 100. Now why that's correct? It's not simplified, so let's simplify it. 3, divide each of them by 4. 4 goes into 12. 3, 4 goes into 100, 25. So the probability of picking a red, replacing it than picking a blue is 3/25. Now let's do one that is a dependent problem. The probability of picking a red, not replacing it, that is a big deal. If you read that in a word problem or you ever see it, underline it. You want to make sure that you know you're not putting that back. And then getting a blue. So we basically start out the same, but I like to write the probability of red and then blue because something is changing this time. So we still say red times blue, but what happens here is there's still 4 out of 10 reds, but if I took a red and I do not replace it, yes, there's still 3 blues, but now there's 1 less total. So let me say that again. First we pick the red, there's 4 out of 10. Let's pretend I picked that red. I don't know for sure if I'm going to, but let's pretend I picked that red. Now there's still 3 blues, but total there's only 9. So instead of 4/10 times 3/10, we have 4/10 times 3/9, which gets us 12/90. We can divide those both by 6, and we get 2/15. All right, so that's the basic. This is the dependent event. One event depends on the second event. We're going to do one more, and that will conclude our notes. So this time the question is a yellow and a yellow. So we're going to stick to the left side over here. So there are 2 yellows out of 10. So we say 2 out of 10 times 2 out of 10 gets us 4 out of 100. Divide both of those by 4 to simplify it. 4 goes into 4 once, 4 goes into 100, 25. So we have 1 out of 25. Now let's jump over to our dependent. So we want the probability of yellow and then a yellow, no replacement. So let's look up here. We have 2 yellows. So the first probability would be 2 out of 10. But now I take 1 out. How many yellows are left this time? 1. Because I got rid of 1 yellow, there's only 1 left out of 9. So when I do my probability, it'll be 4 out of 10. I'm sorry, that was the wrong problem. Let's go down here. My bad. So we have yellow times yellow, 2 out of 10 because there was 2 yellows, times 1, because remember I took away 1 yellow and I did not put it back, over 9, because when I took out that 1 yellow, it took 1 from my total. So now I do 2 times 1 is 2, 10 times 9 is 90. Simplify them both by 2, 1/45. So the big thing is dependent events. Let's move on down here. Dependent events, you're not going to replace it. You could eat it, like if it says you have a gumball and you take a gumball and then you eat a second gumball. Well, you can't put it back, so that's a dependent event. If I'm getting socks out of my drawer and I pick 1 sock and then I pick another sock, I didn't put the first one back, so that's dependent. So remember, independent, you replace it. Dependent, you don't. Good luck.